happen on the final exam. All right, so that's why these concepts jumbled up worksheets are really good to help you get ready for those quizzes, help you get ready for the final exam and the tests as well. So what I'm going to do in this video is I'm gonna go through some of the problems here, and you can use this almost as a video key to the worksheet, but I would highly encourage you to work through this on your own first before you watch the rest of this video. All right, see if you can go through and identify what skill you need for each problem. Don't actually solve it yet, but just read the problem. Like read this first problem and think, what of these things are you going to use to solve this problem, right? Choose one of these skills from the box and tell me, what are you going to do here? And then once you've done that for each problem, actually go back and do it. All right. So the biggest part with this kind of a worksheet is just to identify the skill that you actually need. What kind of a problem are you dealing with? And that focuses your mind on what to do next. Okay. So here we go. I'm going to look at problem number 1. Like I said, the only part of this I'm going to do is I'm going to identify the skill. If you want to see the actual work, like where we crunch the numbers and everything, you can look at the key that I provided on My Open Math. Okay, so let's read this one carefully. It says, you work for a company that produces hand sanitizer. It says you produce bottles of hand sanitizer that are labeled 295 milliliters. Your quality control engineers gather a random sample of bottles and obtain the following data. So we've got some data here. And they want you to find the mean and the standard deviation for the volume of hand sanitizer from your sample and interpret these numbers in context. So this is just, here's some data, find the mean and the standard deviation. Right? Easiest way to do that is to use 1var stats. So this is just a simple 1var stats problem. Okay, we can find a mean and a standard deviation for the sample just by using 1var stats. All right, so that's really all there is to that one. Like I said, you can come back and run the 1var stats on that data and compare your answer to what you got on the answer key to make sure you got that right. So let's read number 2. Right, so again, working for the same company that produces the hand sanitizer, you produce the bottles that are labeled 295 milliliters. Your quality control engineers gather a random sample and obtain the following data. It'll be the same data from number 1. We want to estimate the mean volume of all bottles of hand sanitizer at a 95% level of confidence and interpret the results in context. Okay, so your keywords here, estimate, right? This is asking you to estimate something. And estimating is done using confidence intervals. And the other big clue is that they want it done at a 95% level of confidence. So when they say that, it's pretty obvious that they want you to do a confidence interval with the data that you have up here. Okay, so this is going to be a confidence interval. The question is, which one? Okay, so this will be a confidence interval for sure. We're estimating a mean. Right, so that's a big clue. So if I look up here, we see 3 different intervals. We see a 1 prop z, a t interval, and a z interval. The t interval and the z interval are for estimating means, and the specific one that we're going to use depends on whether or not we have a population standard deviation for that problem. And if you read this one carefully, it does not give us a population standard deviation, so this one is going to use a t interval. Okay, so this is a confidence interval for a mean, which means we're going to use a t interval because we do not know the population standard deviation here. Okay, like I said, you would come back later. You can actually run that confidence interval on your calculator and compare it to the answer key. All right, you work for a company that produces hand sanitizer. Yet again, you produce bottles with the same volume in it, and I misspelled label, so that's awesome. Your quality control engineers gather a random sample of bottles and obtain the following data, same data as number 1, okay? Is there evidence at a 5% level of significance that the mean volume of all bottles of hand sanitizer is different than the label of 295? Okay, so this is a claim, right? When we print that volume on our bottles, we're making a claim that the volume is 295 milliliters. We're testing whether or not our claim is good, or is the actual volume different than the 295 that we printed. So this is a hypothesis test. We're testing something. And the other key clue here is that they gave us a 5% level of significance, which is typically wording that's used when we do a hypothesis test. Okay. So this is definitely hypothesis test. And the question is, what hypothesis test are we going to use? So if I go back up and I look at my options box here, you'll see 3 different tests that we learned about this semester: a z-test, t-test, and a one-prop z-test. And the z-test and the t-test, those are for means. The one-prop z-test is for proportions. And we are testing the mean, right, according to this problem. So it's either a z-test or a t-test, and that depends on whether or not we know the population standard deviation. And I'm just scanning it one more time to see if they gave me that, and it doesn't look like they did. So this is going to be a t-test. Okay, so that's what I'm going to be doing to solve that problem. Make sure that when you do run your hypothesis test, practice interpreting the results in context. Okay, that's important. All right, let's look at number 4. It says, it turns out that, unknown to your engineers, the bottles of hand sanitizer are approximately normally distributed with a mean of 295.1 milliliters and a standard deviation of 0.12. So they just gave us everything about the population. They just told us the population mean, the population standard deviation. We know everything about it now. It wants us to find the probability of obtaining a random bottle of hand sanitizer with a volume of less than 295 milliliters. Okay, so this is probability. We're not testing, we're not estimating, we're not finding a mean or a standard deviation. We're finding the probability that a single bottle of hand sanitizer will have a volume of less than 295. And this is from a normally distributed population. So this is just going to be a normal CDF. So just a plain Jane normal CDF, right? You would draw, make sure you draw your curve, the normal curve that you're going to use. Right? So you should have a normal curve, and you're going to mark your boundary, right? Since they want to be less than, you're probably going to shade an area to the left of some boundary. And then you'll set up a normal CDF with your left and right bounds and your mean and your standard deviation there. Okay. All right. Let's go to number 5. Let's read this one carefully. It says, it turns out, and again, unknown to our engineers, the bottles of hand sanitizer are approximately normally distributed. Okay, so the shape is normal. The mean is 295.1, so we know the population mean. And the population standard deviation is 0.12 milliliters. All right, so we know everything about this distribution, which is great. They want us to find the 10th percentile for hand sanitizer volume. All right, so what amount of volume would be at the 10th percentile for this distribution? Okay, so in other words, what a percentile does, right, if you think about a distribution, a normal one specifically, is it separates the top 90% from the bottom 10%, right? So we're going to have 10% over here and 90% over here, and there's some volume that separates those two areas. So this is an inverse norm. This is an inverse norm for sure, because we know the area to the left, but we need to find the actual volume. So we're going backwards from what we would normally do with a normal CDF. No pun intended. Okay. Let's look at number 6. It turns out that, unknown to your engineers, the bottles of hand sanitizer are approximately normally distributed. Okay, all the same information as the last problem. We got the shape, center, and spread here. Find the probability of obtaining a pack of 3 random bottles of hand sanitizer with a mean volume of less than 295. So again, we're calculating a probability, right? So again, it's not a test, it's not an interval, it's a probability that we're calculating, and we're calculating it from something that is normally distributed. So I'm definitely thinking this is a normal CDF. That's what we use to calculate probabilities, but we're not doing the probability of a single bottle of hand sanitizer. We're finding the probability that a pack of 3 random bottles of hand sanitizer has a mean volume of less than 295. So this is not only a normal CDF, but it's going to be a sampling distribution. Okay, so this means that we have to adjust the population standard deviation, right? We have to do the population standard deviation divided by root n here because it's for a mean. Okay, if that were a proportion, we would use the other one with the 1 minus p times p over n all inside of the square root. So we have to make that adjustment since we're taking 3 at a time instead of 1 at a time. Okay, let's go to the next one. Number 7. The engineers would like to estimate the proportion of all bottles of hand sanitizer that are underfilled. Okay, so, and I noticed the word proportion here. So proportion, underfilled. They gather a sample of 260 bottles, and 47 of them are underfilled. Okay, so sample size, we got a sample size there. We've got, let's call this underfilled as a success. So we got 47 successes out of 260. So we have a sample proportion there that we can calculate, or a point estimate, if you will. Keyword here, estimate the proportion of all bottles of hand sanitizer that are underfilled at a 90% confidence level. We're definitely doing a confidence interval here. This is a confidence interval for proportions. Okay, we're trying to figure out what the actual proportion is at a 90% confidence level, and then we want to interpret the results. So if I went back to my box with the options on there of the 3 intervals, we're going to be doing a 1 prop z int here. Okay, that is the function on the calculator that'll calculate that confidence interval for us. Might also try doing it by hand. I know you don't want to, but making sure that you run through all of the key parts of the confidence interval by hand could be valuable to you. But this is definitely going to be a confidence interval for proportions. So we'll use the 1 prop z int to crunch those numbers. All right, let's go to number 8. So it turns out that 20% of the bottles are slightly underfilled. Okay, so we're just going to go ahead and accept that 20% of bottles are going to be slightly underfilled. Sounds fine. Find the probability that 50 random chosenly bottles, if we took 50 of them, 8 of them would be underfilled. Okay, so turn 20% probability that 50 out of 50, that should say out of, that out of 50 randomly chosen bottles, 8 would be underfilled. Sorry about that. I hope that wasn't too confusing. But we want to find the probability that out of 58 would be underfilled. So this is actually binomial if you think about it, right? Because I'm going to take a bottle and I'm going to weigh it, and it's either going to be underfilled or it's not. Okay, so this is binomial because it has 2 outcomes. We have a set number of trials. We're taking 50 bottles, and the probability of success is going to be the same for each one. There's a 20% chance that it's underfilled. So this is definitely binomial. And if we're thinking about it, the probability of success is 0.2. The number of trials is 50. And we want to find the probability that 8 of them are underfilled. So this is a binom PDF. This is a binom PDF because we're trying to find the probability that exactly 8 are underfilled. So you might want to go back, if we haven't done binomial stuff in a while, so you might want to go back and review the notes that we did in class and make sure you look at the difference between binom PDF and CDF. So remember, CDF adds up the probabilities from that distribution from one point to another. A binom PDF simply gives us the exact probability for a certain value. Okay, so that's how I knew that was a PDF, because they wanted to know exactly 8. So let's read number 9. It says in number 9, it turns out that about 20% of the bottles are slightly underfilled. So just like number 8, find the probability that 50 random chosenly bottles that out of, again, I don't know why that got cut out of there, probability that out of 50 randomly chosen bottles, more than 12 would be underfilled. So again, this is binomial. It's almost the same exact problem as number 8 with all the same parameters, right? The proportion is going to be 20%. The sample size is going to be the same, right? The number of trials or whatever is going to be the same. But this time they don't want an exact number, they want 12 or more, right? So this is a binom CDF. And you might remember that if we do a more than, it's going to be 1 minus binom CDF, because the way the binom CDF function works is it goes from 0 up to. So if we do a 1 minus binom CDF up to 11, and we subtract that away, then what's left is 12 or more. So I would actually specifically write here a 1 minus binom CDF to set that up correctly. Okay. Last one here, we've got a group of concerned customers that claim so that's a keyword there, claim that over 15% of the bottles are underfilled. Over 15%. All right, the engineers gather a random sample of 260 bottles, 47 are underfilled. Is there evidence, keyword there, at a 5% level of significance that over 15% of the bottles are underfilled? So essentially, it doesn't say it directly, but we are testing a customer claim. So when we test a claim, that's going to be a hypothesis test. Okay, so we're going to be doing a hypothesis test here. And what exactly are we testing? Are we testing a mean or a proportion? And so 15% of the bottles are underfilled, over 15% of bottles. So this 15% is a proportion. So we're going to be doing a proportion hypothesis test on a proportion. So that is going to be a 1 prop Z test when we go to the calculators for this one. I'll even help you set up the null and the alternate hypothesis here. All right, so the customers claim that it's over 15%. So we'll assume that the proportion is 15%, right? Make sure equality goes in the null. And then our alternate hypothesis would be that it's greater than 15%. So I'm going to say the proportion is greater than 0.15. So that would be the setup for the null and alternate hypothesis there. And then you would go and run your 1 prop Z test with the information that they give you on the problem. All right, guys, hopefully that was helpful running through the Concets Jumbled Up worksheet. Like I said, it should run you through the entire gamut. You know, like trying to get all of these on one worksheet is a difficult thing to do. It's also difficult to kind of stretch your mind over all of the things that we've done this semester, because we've done a lot. So make sure you work through these Concets Jumbled Up worksheets. If you didn't do them from the previous weeks, go back, use those as a tool to test yourself and challenge yourself with these concepts and skills. All right, and if you get stuck on any of them, just let me know. We'll set up an appointment. We can work through a few of the problems and talk them through. All right, guys, have a great day. Good luck on your homework and your quiz.